Now I'm going to present you the background of this work. As you all know, carbon dioxide and hazardous gas emission have increased recently. The reports show it has increased 50% in last decade. The reason behind this is burning of fossil fuels and using natural resources to meet our energy demands. Unfortunately, this demand is increasing day by day. In the next 2 decades, the global demand of energy will increase significantly. One of the main consumer of this energy is the airport industry. For instance, in China, the airport industry consumes up to 8% of the total energy in all transport industry. In Indonesia, one of the terminals use up to 8 megawatt electricity just for lighting purposes. So to deal with these issues, the scientists and the researchers are inventing new ways which are eco-friendly to generate electricity. The topic of our research and this presentation is almost similar. We're implementing RPG to produce electricity. So what is RPG? RPG, or the road power generation, is designed to utilize unused kinetic energy from any vehicle and transform it to electricity. For example, a moving vehicle, it can be a car, it can be a bus, or anything else. So we can use this technology to produce more electricity in the airport as well. The government of Bangladesh has proposed an extension for Hazrat Shahjalal International Airport. So the JICA, or Japan International Cooperation Agency, and the CAB, the Civil Aviation Authority of Bangladesh, have been working on the expansion project for a few years now. So these new fleets of the aircraft will move past this RPG technology and it will increase the electricity production. Currently, the airport can host up to 8 million aircrafts. And in future, in 2035, it is predicted that almost 27 million aircraft will be hosted in this airport. So these new fleets and the new taxiway can increase the opportunity to produce more electricity from this proposed method. There is some caveat to this. In our research paper, we're proposing something different. We're proposing a conveyor roller, which will be used instead of the bump. The aircraft will move towards the conveyor roller. The nose wheel of the aircraft will transmit the mechanical energy to the proposed machine, and it will drive the mechanism, it will drive the belt. And the belt will then move the shafts, and the shafts will generate the electricity. This is how we are going to produce electricity from an airport taxiway. This will be installed in a taxiway because we don't want to get into the hazards of takeoff and landing. If we put it in the runway, there may have some problems with takeoff and landings. So we want to avoid that. Therefore, we're proposing it to be installed in the taxiway. And it doesn't depend on the weather. It doesn't depend on the sun or the wind or anything like that. It totally depends on the traffic flow. If we have more aircraft, the production of the electricity will be increased. This is the whole notion of this project. So this is how our project will look like, the model will look like. So as you can see, we have a aircraft here. It will drive this belt, and you can see here we have 4 shafts here. Conveyor belt will drive the chain, and it will also move those shafts, and those shafts is connected with the generator and some circuits and stuff like that. It will produce the electricity, and then the produced electricity will be distributed accordingly. So how do we calculate like how much electricity it will produce? So therefore we have made an estimation and a prediction. So what we have done is we're considering 5 aircrafts, ATR 72-8, Boeing 737, Boeing 777, and Boeing 787. So we're considering this because they are the most popular and most flown aircraft in Hazrat Shahjalal International Airport. And what we're going to do, we need to find the center of gravity, because we need to find the normal force. And to find normal force, we'll need to find the weight of the aircraft. And find the weight of the aircraft, we need to find the CG. So how do you calculate the CG? We use this equation here. And after calculating the CG, we'll calculate the load, the static load exerted by the nose wheel. These equations here, they will help us to calculate those force. Our target is to find the normal force here. And in the first equation, you can see we have the mass of the aircraft, the acceleration. T represents the thrust, then there's drag D, and mu R is the coefficient of friction. Then we have load and we have lift force, and then we have to find the Fn, the normal force. After finding normal force, we will be able to find the friction force or roller resistance. So as we can see, like Boeing 77 is exerting more force to the conveyor belt because it has more weight and it is a wider body aircraft. Therefore, it's going to produce more power. That's the prediction here. So if you're going to calculate RPM, because the nose wheel will drive the mechanism and it will have some torque. So we need to find the torque first. Then the torque will provide the RPM. So the RPM calculation will do that with this equation. As we have four shafts, so we are multiplying this with 4. We can find the torque and RPM for every 5 types of aircraft. Similarly, we'll use this circuit diagram, generate the electricity. And for stabilizing the electricity can be difficult for any kind of renewable energy. Therefore, we are using Jenner diode to stabilize the electricity production in the system. And these formulas will be used to calculate the overall output. From this table, you can see Boeing 77 produces highest amount of power, then 787, Boeing 737, and Dash 8. And ATR 70 produces the lowest amount of energy because of its lesser weight. And it's a very narrow body aircraft, so the aircraft will produce less energy. So from these calculations, we can conclude in 2 ways. If we have higher amount of traffic flow, we're going to have higher amount of energy and electricity. Similarly, if our aircrafts have more weight and it has more wider body, we're going to produce more electricity. So the first one, we have calculated using the aircraft movement data to predict this model. Like according to the projection, this projection, we can say in 2015, when we had like 8 millions of traffic, we could have produced 39.4 gigawatt electricity in that year. But as we didn't have the technology yet, that's why we could not produce this much, right? This is the prediction. Similarly, in 2020, we could have made 63.8 megawatt, and in 2035, we'll produce 142.5 megawatt electricity using this model. So in conclusion, we can say, unlike any solar panel or any other devices, for example, wind turbine, there's other ways to produce sustainable energies. Unlike those, our proposed model is not dependent on the weather or the sun. It's solely dependent on the movement of the aircraft, movement of the traffic, and stuff like that. However, further study is needed to improve our model because we haven't considered dynamic analysis here. We have considered some part of it, but we did not go detailed inside of it because this is the initial project. And external and internal resistance, for example, the friction forces between those shafts and belts, we haven't considered that in our calculation. So those can be included in the calculation for predicting precisely how much electricity we can produce. Similarly, we need to think about adverse weather condition. For example, the snowing, those raining, these conditions we have to investigate, like how it will affect our system and how can it protect them, right? And the most important part is we have to build a prototype. We have to make sure that it works properly. If we're successful in building the prototype and we can go forward, I think this research work, this specific topic, could help us build a self-sustained airport in the future. Thank you so much for giving me time. And these are the references we have used. And thank you so much for having me here.